Welcome to my class. So today we're learning about impulse and how it relates to momentum. And we'll be using these three equations. So we'll be using these three equations. Momentum equals mass times velocity. Impulse equals force times time. And these two are related because impulse is equals the change in momentum. So we'll be experimenting today with a couple different experiments to show how changing a few of these variables can reduce the impulse or increase the impulse.
Okay.
So Ms. Bosange, when you catch a ball and you don't have a glove, how do you catch it? You just catch it like that?
Or like probably like
that?
Probably like this.
What if they throw it really hard?
I would duck.
You would, okay. Okay, ready? Paige, if I threw a ball at you right now, do you think it would hurt more if your hand was like this and just hit it, or if you gave a little bit?
It would hurt more if you just had it right here, because when you move it back with the ball, it extends the time of impact.
Okay.
Wow. Mm-hmm. Perfect.
Yeah. So for the lacrosse experiment, crossball experiment, we need to measure how far the distance is between the two people. So Devon will be standing at that binder, and Hitty will be standing at that binder. And so when we find the distance between the two people, we can plug it into our equation so that we can find everything we need to.
Okay, 5.5 meters.
5.5 meters. Go ahead.
So for our two experiments, first we'll be throwing this smaller ball at each other, and then we'll be dealing with a heavier mass using a lacrosse ball. So for the lacrosse ball experiment, like I said, it's a heavier mass, so we have a bigger M variable, and here this is stating that mass times change in velocity equals force times time. So velocity is kept constant over this experiment. So for our two experiments, first we'll be throwing this smaller ball at each other, and then we'll be dealing with a heavier mass using a lacrosse ball. So for the lacrosse ball experiment, like I said, it's a heavier mass, so we have a bigger M variable, and here this is stating that mass times change in velocity equals force times time. So velocity is kept constant over this experiment. So because we have a bigger mass, we're going to have a bigger force. So this just means that it's going to hurt more when we throw the lacrosse ball at somebody because it has this larger mass. And same thing, this has a smaller mass, so a smaller M is going to give us a smaller force. And a way that we're manipulating the force variable is that we are going to try to increase time, because we hypothesize that with a bigger T variable, the force is going to decrease. This ball, so we can then plug that into our equations to solve for time and velocity. Sarah, now.
So this ball has a lighter mass. So when I throw it to Andrew, the force is going to be less than the lacrosse ball because it has a smaller mass. So here we go.
I just need to get my bag up.
Oh yeah.
0.8 seconds.
And now it's going to
Did that hurt, Andrew? It did. It did.
So, are you filming?
Uh-huh.
So now he's going to pull his hand back, increasing the time.
Wait, don't go yet. Okay. 2.4 seconds. And now.
So for our experiment, we're going to use a lacrosse ball to start, and we're going to have someone throw the lacrosse ball to someone else. And because the lacrosse ball has a very big mass, it will have a bigger force because time and velocity are constant, will be the same. And then we'll compare the force that this applies on someone's hand to the force that a wiffle ball applies, because a wiffle So first we mass the objects so that we can plug it into our equation. Okay, so we're going to prove that adding time to the equation of impulse reduces the force. So for our experiment,
I will throw this ball to Hitty, our volunteer, and when she does not move her hands, she is therefore not allowing more time for when the ball hits her, which will result in a larger force, and we'll see her reaction. Okay, ready? Alright, now let's try that again. Now, Hitty, move your hands back, because what that's going to do is going to create more time, and thus a smaller force, and it should feel better. Okay, ready?
Go ahead.
So we have made a chart with all of our information combined just to put a conclusion to it. So our point here is that when we increased the time, you had a smaller force. And you can tell, looking at the lacrosse ball column, our time one was 0.8 seconds. The force that correlates with that here is 1.4 newtons. When Hitty moved her hand back, that created more time, 2.4 seconds, but also resulted in a lesser force, 0.14 newtons. So if you compare these two forces, you can tell exactly how affecting time changes the force. And the same.
How do you catch it if you don't use your hand? Okay, you don't want to be in our video?
No. Are you videoing me?
Yeah.
Don't.
You might as well,
Seriously, I
right?
look terribly fat on camera.
Oh,
You don't have to get asking the camera more than once.
Oh, what's the camera for?
physics video.
I don't want to be on here.
That's okay, you look good.
No.
Oh,
you can ask me again.
Alright, ask Paige.
They forcibly videoed me when I said don't put me on camera.
I did not. I did.